Hello everyone, in this lesson we will discuss antiderivatives. Learning objectives, we will find the general antiderivative of a given function, explain the terms and notation used for an indefinite integral, state the power rule for integrals, and use antidifferentiation to solve simple initial value problems. Well, that's in our next video. Exploration. Consider f of x is equal to x squared. Let's just think about it. Find f prime of x. Now, if you remember the power rule of derivatives, you want to say f prime of x is equal to 2x. That's by the power rule. Bring the 2 over. That goes 1 down. Then, determine a way to reverse this process. So to try to reverse this process, remember you brought the 2 over. And then you went 1 down in the exponent. So therefore, maybe you want to go 1 up on this for the exponent from 2x to get to x squared. And then because you brought the 2 over, and maybe you want to bring this 2 under. Or divide by another 2. Okay? Divide by, let's say, 1 plus 1. Whatever will undo that 2. Right? Divide by, another 2 to undo this to get a 1. You want to get a 1 right here. So you want to divide by this exact same thing. So probably divide by 1 plus 1, perhaps. Okay, what about if you had x squared plus 5, x squared plus 5. Now, the derivative of this, f prime of x, will still be equal to 2x. And the 5 just somehow, because it's a constant, derivative of constant was equal to 0. And then to get back to the 2x plus 5, now it's probably not that easy. The x squared plus 5, we have our 2x. If we do the same idea up there, divide by 2, and then this goes 1 plus 1, you still get that 2. But you need something else here. You need something else here. What can we do? Okay, there's some other functions whose derivative is the same as in parts B and C. So whose derivative is 2x. So those examples would be like, let's say x squared plus 1, x squared plus 2, and so on and so forth. Okay, so anything with like an x squared, or which would be equivalent to some x squared thing, minus 1, whatever, x squared minus 1. So all those, right? So there is a family of functions who produce the same derivative, right? So in all these, there's some constant. So any x squared plus some constant. So any x squared plus some constant. Plus constant. All right, so that's the description, right? So anything like x squared plus some constant, okay? And this is very interesting because we're going to call this constant a special later on. And so let's look at some definitions. A function f, this uppercase f, is an antiderivative of a function lowercase f if the derivative of uppercase f is equal to lowercase f, f of x, for all x in the domain of f. Okay, so it's an antiderivative. Okay, just like x squared plus 5 here would have been like our uppercase f, and then our f prime of x would be the f prime of our uppercase f, and then we would call this new function our lowercase f of x, right? The derivative, we'd call that lowercase f of x. Right? Pretty interesting notation here. So let's get used to this kind of notation. The general form of an antiderivative. Let uppercase f be an antiderivative of function lowercase f over an interval I. Then 1. For each constant, uppercase c, the function uppercase f of x plus c is also an antiderivative of the function lowercase f over I. 2. If uppercase g is an antiderivative of the function lowercase f over I, there is a constant c for which g of x equals uppercase f of x plus c over I. In other words, the most general form of the antiderivative of lowercase f over I is uppercase f of x plus c. Right. So I got some examples. Find the general antiderivative of this function f of x is equal to 3x squared. So we have lowercase f of x is equal to 3x squared. So we want to find an uppercase f of x that has the derivative 3x squared. So which function has the derivative 3x squared? The function that has derivative 3x squared is x cubed. So the d dx, because the d dx of x cubed is equal to 3x squared by our power rule, then uppercase f of x is equal to x cubed plus, you have to plus this constant, could be plus or minus any other constant. When you take the derivative, that derivative will be equal to 3x cubed. So then uppercase f of x is equal to x cubed plus c is the antiderivative of 3x squared. Okay. Next question, let us try to find the antiderivative of cosine of x. Okay, the solution. F of x is equal to cosine of x. So it is asking what function is there. If you take the derivative of that function, you will get cosine of x. This function we know is sine of x. Sine of x has derivative cosine of x. So because dd of x of sine of x, d dx of sine of x is equal to cosine of x, then uppercase f of x is equal to sine of x plus c is the antiderivative of cosine of x. Let us introduce some more notation. Definition. Given the function f, the indefinite integral of f denoted integral. Let us introduce some more notation. Definition. Given a function f, the indefinite integral of f denoted integral sine f of x dx is equal to uppercase f of x plus c. The symbol looking here like an S is called the integral sign. The expression f of x is called the integrand, and the variable x is called the variable of integration. The process of finding an antiderivative is called antidifferentiation or integration. The power rule of integrals. For n not equal to -1, the integral of x raised to the n dx is equal to x raised to the n plus 1 all over n plus 1 plus c. So the integral of 2x dx will be equal to 2 times x raised to the 1 plus 1 over 1 plus 1 plus c. And that would be equal to x squared plus c. The graph shows the family of antiderivatives of f of x is equal to 2x. So it's all these quadratic curves begin with x squared plus 1, x squared plus 2, and so on, x squared minus 1, x squared minus 2, so on, going downwards. An infinite number of them, several in between all of these and above and below. Okay, let us look at just some more rules, integral rules, and a lot of these we know just looking at them being the opposite of differentiation, just looking backwards, and so some of these we can derive later on. So integral of 0 dx is just equal to c, that's a constant. Because if we had, let's say, differentiated a constant, all constants, they become 0, right? So it's just like looking at it backwards. Integral of kx, not kx, but k dx is equal to k times x raised to 0 plus 1 over 0 plus 1 plus c is equal to kx plus c. And integral of x raised to the n dx is equal to x raised to the n plus 1 over n plus 1 plus c. We learned that earlier on. Integral of 1 over x dx is equal to ln of the absolute value of x plus c. Integral of e to the x dx is equal to e to the x plus c, and so on and so forth. Right? Learn those rules, and let's apply them quickly or briefly to some problems. Verify each of the following statements is correct by showing that uppercase f prime of x is equal to lowercase f of x. So the integral of x plus e to the x dx is equal to x squared over 2 plus e to the x plus c. We want to show that it is true that the integral of x plus e to the x dx is equal to x squared over 2 plus e to the x plus c. So this x plus e to the x, we're going to denote that as lowercase f of x. And this x squared over 2 plus e to the x, we're going to denote as uppercase f of x, and then plus c just comes down. So we want to find the derivative of f uppercase f of x, so that's uppercase f prime of x, will be equal to d dx of x squared over 2 plus e to the x plus c. So we take the derivative, use the power function rule, of x squared over 2. That will bring the 2 over, so that becomes 2x raised to the 1 over 2 plus derivative of e to the x will be e to the x times 1, which is just e to the x. And then derivative of c is 0. So then this simplifies to give you x plus e to the x, which is what we wanted to show. We got that x plus e to the x as our lowercase f of x. So then the statement is correct. Integrals. Properties of indefinite integrals. Let uppercase f and uppercase g be antiderivatives of lowercase f and g, respectively, and let k be a real number. For sums and differences, the integral of f of x plus or minus g of x dx is equal to uppercase f of x plus or minus g of x plus c. Constant multiples. Integral of k times f of x dx is equal to k times uppercase f of x plus c. In general, the product of antiderivatives is not the antiderivative of the product. Evaluate the following. Integral of 5x cubed minus 7x squared plus 3x plus 4 dx. So using our properties, the integral of 5x cubed minus 7x squared plus 3x plus 4 dx, we can separate this by our sum and differences rule. Integral of 5x cubed dx minus integral 7x squared dx plus integral of 3x dx plus 4 dx. And that's going to be equal to, if we factor out the 5 by our constant multiple rule, 5 integral of x cubed dx minus 7 integral of x squared dx plus 3 integral x dx plus 4 integral of 1 dx. And then by our power rule, this would be 5 over 4 x raised to the 4th, because what we do is bring the 3 under, add the 1, and then add the 1 to the 3. And likewise, I bring the 2 under, add 1, so that'd be 7 over 3, plus add 1 to the 2.